Welcome to April at Empirical's SDA Learning Center. In the last video, I demonstrated a way that multiple individuals could work simultaneously in the same project drawing set in AutoCAD Electrical. In this video, I want to discuss the conversion process from AutoCAD to AutoCAD Electrical and illustrate a couple of solutions to the primary conflict that I've encountered during every transition I've done. That is, how to handle missing schematic information for wiring diagram annotation. Wiring diagrams are a product of the schematics, and they're only as good as the information contained within the schematics. AutoCAD Electrical requires a schematic representation of each symbol, wire, and cable in order to write that information to the wiring diagrams. There are multiple ways to approach this problem, and in this video, I will illustrate two conversion approaches on each end of the spectrum, each with their own sets of pros and cons. One would be a supplemental approach, where you keep the look and feel of your current standards, but add missing schematic material to the project by creating and adding additional standalone reference schematics to the project file. And the second approach is an additive approach, where you sacrifice the current look and feel of your standards by adding missing schematic material into your current design standards. This video will demonstrate how these two approaches work by drawing an AC cable between an AC distribution panel and a protection and control panel within the control house. This is an AC schematic for a line breaker protection panel. In this first example, we've converted this drawing, as well as a standard project, to be an exact AutoCAD Electrical replica of the previous AutoCAD version of this standard panel. The option comes with some challenges. Some of the cables on this drawing are connected to another panel AC schematic drawing, which works perfectly with AutoCAD Electrical, but many other cables on this drawing may reference either a schematic diagram or a connection diagram, depending on the station design in which panels are being used. One such cable is the AC schematic cable located at the bottom right of the drawing. This cable always references the AC distribution panel connection diagram, not another schematic diagram. AutoCAD Electrical requires both ends of this cable to be connected to schematic symbols, not just for proper annotation and referencing, but also because AutoCAD Electrical draws on schematic information to produce cable from to, wire from to, and other reporting. Since this is a conversion example where I chose to maintain the current look of the customer's current AutoCAD standards, I've chosen to create supplemental design standard schematics to fill in the missing gaps in the schematic material. In this case, I've created a new standard AC distribution schematic drawing based on its vendor drawing, and I've added that to the main substation project file. I've designed the supplemental standard such that I can copy it out of Vault and add it to any substation design I need for cabling and reporting. The same principle applies to any other standalone panel schematic material that was previously unaccounted for in the schematic diagrams. In the project tree to the left, I've organized my project file into the main protection and control panels, standalone control house panels, and yard panels. Drawing files with the numbers marked with an S suffix indicate which drawings are supplemental schematic diagrams. These supplemental schematics won't be included in the final construction package deliverables. They are solely for design purposes and correspond with the connection diagram drawings that will be included in the final construction package. Before I explain any more about the schematic supplemental diagrams, I'll get started by editing the AC schematic cable at the bottom right. I'll match the tag. And I want to make sure that my format deref attribute has the correct format for cross-referencing. The format deref attribute will push to a multi-line deref attribute that pulls in the %D drawing property from the supplemental schematic drawings, as well as the %S drawing property for the drawing number cross-reference. The reason we will use %S is because it allows for the same drawing number value to be pulled into the schematic drawings as if it were referencing the connection diagram drawing without actually duplicating the file name in Vault. I've also designated the cable as a master symbol because though the deref section of the SDS help file indicates that these values can be pulled between cable fan-ins by default, we've had to give them an additional master reference designation in order for the deref cross-referencing to work properly. So after that, I'll just hit OK. Then I'll match the signal arrow codes using Cable Update SIG codes under the Cable Fan and Drop-Down list of the SDS Schematic tab. I'll select the cable bubble and the signal arrows and hit Enter. Now I want to save, and I'm going to open the AC distribution panel connection diagram and select which breaker I want to draw the other end of this cable to. I'll select the first single pole breaker, CB77. Now, I'll go ahead and open up my supplemental AC distribution panel schematic and locate CB77. All breakers in this supplemental schematic have been pre-wired with child cables and destination signal arrows. All I have to do is change the default tag to whatever cable I want to match the cable tag coming from the parent side of the cable, and rerun SDS cable SIG fan update to match the destination signal codes to the new cable tag. Select cable SIG code update, select the bubble. Now this end of the cable is matching the other end, completing the cable run. Before I leave the drawing, I'll again have to make sure that I reference this symbol back to the parent master using the SDS ref only tool in order to get the deref cross-referencing I need. This step will obviously become obsolete if this gets corrected in the tool. Now I can save and move on to my AC distribution panel connection diagram. And I can surf back to the parent and verify that my connection is made. So from here, I'll select SDS Panel WD, go over to the Add Anno button, keep the defaults, and select CB77 for annotation. The connection diagram cable will momentarily have incorrect referencing as shown in the automatic deref cross-reference information, but that will change after I annotate the other end of the cable. Verify that my format deref is the format that I want to pull in the drawing property cross-reference information, as well as the drawing file name on two separate lines. Next, I'll open up my wiring diagram for my main panel and draw on the other end of the cable. I'll locate RC, terminal strip, delete the template, and under the SDS Panel WD tab, I'll select Anno Single Pick and just pick on those two annotations. And I can see they are connected because I have CB77 pin 77 and CB77 pin G for the ground bus. Now I'll select the cable Anno tool and draw my cable. Now my format deref attribute must be missing a variable, so I'll go ahead and click Edit Component, and under Show as Miscellaneous, I can see that I don't have the %D in there to pull in that drawing property, so I put %D in the pipe character, and now that's going to break that into 2 lines. Once I update the database and save, I'll go ahead and rerun SDS deref and get the cross-referencing information I'm expecting. Q-save the drawing, rerun SDSDref, select the bubble, and there I have my drawing cross-reference information on 2 lines, just as expected. After I straighten this attribute out a little bit, I'll go ahead and zoom out, Q-save, and close the drawing. On my way out of this project, I'll rerun the SDSDref command to update the connection diagram with the correct panel reference and drawing reference. As well as on my AC schematic. I'll rerun SDSDref, select the bubble, and you can see I get my matching CD2 that corresponds with the connection diagram cross-referencing. This is the %D for the CD2 template drawing, as well as %S. So just as an explanation as to how I'm actually getting that information. This conversion option allows us to maintain the current look and feel of our customer's current design standards. The pros of this approach are familiarity of the design with your engineering, management, and construction personnel, and consistency, particularly when considering integrating new AutoCAD electrical designs into existing AutoCAD designs for brownfield applications. The cons are that you'll be creating additional drawings that are going to have to be maintained by your AutoCAD electrical librarian. The upshot is that these drawings, like the distribution panel shown in the example, can be drawn to match a vendor-specific design. When new vendors or configurations are used, it can be pre-built with flexibility for copying and editing to meet your needs of any vendor. Another completely different approach to converting AutoCAD to AutoCAD Electrical is to add previously non-existent schematic material into your current design standards. We've converted this drawing, as well as the standard project, to work with as much standard AutoCAD electrical functionality as possible. This option also comes with some challenges. Like before, some of the cables on this drawing are connected directly to another panel AC schematic diagram. This causes a lot more duplicate symbols to be managed through the master reference tool than previously required. The overwhelming majority of the cables on this drawing mostly reference a connection diagram or a junction box, so we've added terminals and cable marker symbols where cable bubbles previously existed. Just as in example 1, I'm going to focus on the same AC cable located at the bottom right hand of the drawing. Instead of editing a cable bubble and signal arrows like in the example 1, this cable now has a circuit breaker schematic symbol and schematic cable marker symbols to edit. I'll make 2 edits, one to the circuit breaker schematic parent symbol and another to the parent cable marker. The elements for annotation, referencing, and cable wire to from reporting is built right into the same location. I'll start by assigning the same CB77 as the previous example, and then I'll go about changing any relevant attribute information. Under Show Edit Miscellaneous, I want to verify my Format DREF attribute. This value will bring in an attribute value from the connection diagram called Panel XREF. All AC circuit breakers from the distribution connection diagram carry the same attribute value, so anywhere in the project where I have an AC schematic breaker will pull in the drawing value. I'll update this child symbol, but I don't want to update the parent connection diagram symbol because I'm not actually updating the symbol. What's actually happening is I'm just referencing another circuit breaker, CB77, on the connection diagram. Next, I'll update the cable marker symbol with the same cable number that I used previously. I'm not going to worry about the Format DREF attribute on this cable marker because none of the information that I need for cross-referencing is going to originate from the cable marker. It's all from the symbol. From here, I'll surf from the schematic circuit breaker to the AC distribution connection diagram to annotate the circuit breaker and draw out the cable. Under the SDS Panel WD tab, I'll select Add Anno, accept the defaults, and select CB77. Also under the Panel WD tab, I'll select Cable Auto Fan, and I'll draw out the cable. I'll go ahead and correct this drop in real quick. Now it's off to the wiring diagram to draw the other end of the cable off of the RC terminal strip. Go ahead and delete the stencil layer. Under the SDS Panel WD tab, I'll select Anno Single Pick, keep the defaults, and go ahead and select both RC11 and RC12. I can verify that CB77 pin 77 and CB77 pin G for the ground bus are referencing correctly, so now I'll go ahead and pick the SDS cable fan-in tool and draw that out. And in this case, my format deref was correct, so the drawing cross-reference information and the drawing number cross-reference come in. I'll go ahead and hide our cable pull list description, and I'll move the attribute over. I'll go ahead and surf on the cable instead here. So I'll surf back to the cable, marker schematic parent, and I'll rerun the SDS deref command to get my panel cross-referencing information. Because that panel XREF attribute was already pre-filled with the drawing number, I get my CD2 connection diagram drawing number. With this conversion option, it allows for using a more traditional AutoCAD Electrical design approach while sacrificing the current look and feel of the customer's AutoCAD design standards. The pros of this approach are straightforward functionality, and no new drawings have to be created, because you're simply adding material to existing drawings. The obvious cons are that you're sacrificing design familiarity that your engineering, management, and construction personnel are accustomed to seeing. There will also be a clash between styles when integrating these new AutoCAD Electrical designs into existing AutoCAD designs for brownfield applications. This video briefly explored two completely different approaches to converting your existing AutoCAD designs and standards into AutoCAD Electrical. These options illustrate two extremes, and there are various middle ground options that can be employed to find exactly the right fit and finish for your AutoCAD Electrical integration. These strategies, like any, have their own sets of pros and cons that your team will have to identify and address throughout the planning and conversion process. I hope this video gave you some ideas as to how you might successfully transition into using AutoCAD Electrical for your protection and control design. The key thing to remember is to thoroughly study your current designs and standards through the lens of an AutoCAD Electrical application to find the gaps in schematic intelligence. If you're lucky, these gaps will be very few and far between. Use this discovery phase to create an implementation roadmap before making any AutoCAD Electrical based decisions. And finally, always keep the end user experience and usability in your mind when creating workflows to keep things as simple and straightforward as possible. And good luck. In next month's video, we'll explore some basic SDS toolkit functionality and how you might be able to use it for better design. Thanks for stopping in again. See you in May with more AutoCAD Electrical content here at the Empirical SD Learning Center.